Dear students, now we shall have a discussion on the physical chemistry unit 1 of MSc chemistry syllabus of second semester MSc chemistry syllabus of Kuvempu University in this session 2. Here we are going to discuss about some of the aspects of quantum mechanics 1, that is unit 1. Myself, Dr. Ganesh Acharya, Assistant Professor, Department of Chemistry, IDSC Government College, Chikmagaluru. Now, as an introduction, we shall have a discussion on one-dimensional time-dependent Schrodinger equation. It is an important equation in quantum mechanics. So, it actually deals with the matter wave or de Broglie wave. That is, according to de Broglie, so matter can behave both as wave and also as particle. So therefore, he gave an equation that is lambda is equal to h divided by m into v. You all know that, right? So coming to the time-dependent Schrodinger equation, we have to start with the wave function. Actually, a wave function is very similar to the amplitude in the classical mechanics. So it can describe the matter or a system completely. So that is actually called as a wave function in quantum mechanics. And if you want to know about what actually are the basic things about the wave function, it should be a single valued and it should be continuous and it must be able to describe the system completely. Okay, so by using this wave function corresponding to the matter wave, we can have an equation for particle wave moving in a positive x direction, and it is given by psi is equal to a e power minus I into omega t minus kx. That is equation 1. The same equation can be further simplified by substituting for omega, that is equal to 2 pi into nu, and substituting for k consisting of the momentum. So we will arrive at an equation psi is equal to a e power minus I by h cross into et minus px. So this is an important equation. If you are not able to remember this, you just remember this equation directly, that is equation for particle wave moving in a positive x direction is given by psi is equal to a e power minus I by h cross into et minus px. This is equation 2. This is an important equation for arriving at the time dependent Schrodinger equation. So what we have to do is, so you have to differentiate this with respect to t and with respect to x to get some of the important equations. Now let us see what we can do further. So now we have to differentiate the equation to twice with respect to x. So we can get dou square psi by dou x square is equal to a into ip by h cross whole square into e power minus I by h cross into et minus px. Okay, so you know that I square, here there is a term I square into p square. So I square is equal to 1. So therefore you can write the same equation as dou square psi by dou x square is equal to minus p by h cross whole square into a e power minus I by h cross into et minus px. Is it okay? Now you know that a e power minus I by h cross into et minus px. What is it? It is the wave function psi. A e power minus I by h cross into et minus px is equal to psi. Now you can substitute for psi here in this equation so that you can get dou square psi by dou x square is equal to minus p by h cross whole square into this part, that is psi. And upon reorganizing this equation, we will get p square psi is equal to minus h cross square into dou square psi by dou x square. Is it okay? So hope you understood how we got this equation. P square psi is equal to minus h cross square dou square psi by dou x square. So this is an important equation, just like equation 2. You should remember this equation also. P square psi is equal to minus h cross square dou square psi by dou x square. Further, we have to differentiate the same equation 2 with respect to t once. So we will get dou psi by dou t is equal to minus I by h cross into e power minus I by h cross into et minus px. So similarly, here also you have a term e power minus I by h cross into et minus px, that is psi. So therefore dou psi by dou t is equal to minus I by h cross into e psi. Okay. So now e psi, what is it? It will be I by h cross. Okay, you can write it as minus I by h cross can be written as I into h cross. Okay, so therefore you will get minus h cross by I can be written as I into h cross. So therefore E psi is equal to I into h cross into dou psi by dou t. This is obtained upon differentiating equation 2 once with respect to t. This is equation 4. So equation 4 also an important equation. Now we all know that the total energy of the system is the sum of kinetic energy and potential energy. So total energy is given by E, kinetic energy is given by P square by 2m, and potential energy is given by V of x comma t, or simply V, that is E is equal to P square by 2m plus V. Now if you multiply this equation by psi, we get E psi is equal to P square psi by 2m plus V into psi. Okay. Now you have term here, that is E psi and P square psi. Already we obtained an equation for P square psi and also E psi. Now you can substitute for P square psi and E psi from equation 3 and 4 in equation 5. Okay. So what is E psi here? You have E psi is equal to I h cross dou psi by dou t. Similarly, what is P square psi? You have P square psi is equal to minus h cross square into dou square psi by dou x square, right? So you can substitute for these two in equation 5. You will get I h cross dou psi by dou t is equal to minus h cross square by 2m into dou square psi by dou x square plus v into psi. So this equation, that is equation 6, it consists of the term time here on the left hand side. So therefore it is actually a one-dimensional time dependent Schrodinger equation. Okay, hope you understood why we call it as time dependent Schrodinger equation. This can be explained or understood from equation 6. So therefore this equation 6 is an important equation called as one-dimensional time-dependent Schrodinger equation. Okay, so you can get the detailed explanation about all this from these references. You can go through these references to make a short notes on this. Thank you very much for watching this video. We will have further discussions in our next videos. Thank you very much.